Yeah. Hi students, I am Dr. Badrinath, and in this video we'll see butterfly gland. Butterfly. Okay, it exactly thyroid gland is looks like a butterfly gland. So that's why I am calling as a butterfly gland. Okay, its size, shape, size also, shape, color is also everything is almost like a butterfly. Okay, feel that you have a butterfly on your neck. This is your syllabus as per your university. Thyroid hormones, analogues, which are similar to that of the thyroid hormones, is called analogues. Inhibitors, which works against a thyroid hormone, is called as a inhibitor. Both words are opposite. Two terms are opposite. Analogues versus inhibitors. Yeah. Here you can see the in your neck. You know thyroid gland where it is? It is in the neck. That's why we'll promise. No, I swear here. Thyroid. You are catching the butterfly. It is very important gland. Super gland. It was. Your growth is also depends upon that only. Body growth, BMS, body metabolic disorders, BMI, body metabolic rate. See here you can see the thyroid gland. Thyroid gland releases the three hormones. Keep in your mind. Thyroxin, T4. How to keep this thyroxin? Triiodothyronine. Triiodo. 3 is there. 3 iodine is there. That's why T3 is there. Tri. Thyroxin. X is there here. X is having a 4 ends. X. 1 end, 2 end, 3 end, 4 end. Because 2 lines, no? 4 ends are there. That's why T4. Like that you can remember very easily. Trick. Simple trick. Okay, 4 ends. Triiodothyronine. Calcitonin. This is also calcium. Calcium is here like that, calcitonin. But calcitonin is not considered as a thyroid hormone. Keep in your mind, it is released by the thyroid gland. But we are not considering as calcitonin as a thyroid gland, thyroid hormone. Keep in your mind. Okay, thyroid hormones means T3, T4. That's it. Okay, and parathyroid secretes the parathormone, parathyroid gland. Where is this parathyroid gland? Parallel. See, there are 4 parathyroid glands are here. 1, 2, 3, 4. 4 thyroid glands are there. Parathyroid glands. Keep in your mind. Thyroid glands having a 2 lobes, right lobe, left lobe. But it is collectively secretes the hormone in the anterior pituitary, posterior pituitary gland. In the pituitary gland, it releases separately, sub-separate. Anterior releases sub-separate, posterior gland, pituitary gland releases the separate hormones. Whereas here, 2 lobes collectively secretes the hormones. Very important. On each lobe, there is a 2 parathyroid glands are here. Here 1, 2, 3, 4 parallelly. That's why it is called a parallel. These two are parallel. These two are parallel. That's why it is a parathyroid gland. It releases the parath hormone. Name itself indicates parath, parallel, parathyroid gland, parath hormone. Yeah, here you can see exactly. This is a thyroid gland front view. If you see from the front, you cannot find the thyroid gland. You cannot see. Okay. If you reverse it back, thyroid gland back view, you can find you can see the parathyroid glands back side. Yeah, this is the structure of thyroid gland and how it secretes the hormone. See, first you see my cursor. This is the entire structure of the thyroid gland. Here, the important function is follicular cells. Very important are. See, you can see here follicular cells. See my cursor. These are the cells. 1, 2, 3, like this. All these are the follicular cells. You can find here follicular cells. This follicular cell very important. Follicular cells is called as a functional unit, not the structural unit. Structural unit, functional unit, these two terms are differently. Functional unit means which function, each unit functions. Structure means just like a building brick structure. In the structure, it is one of the unit. This is the functional unit, it functions. Okay, that's why it is called a FF. FF you can keep in your mind. Functional unit, follicular cells. Right? Okay, now it is good. Thyroid follicle. This is called as a thyroid follicle entire. Each thyroid, this you can see this is thyroid follicle, thyroid follicle. This is thyroid follicle. Each one is called as a follicle. Each thyroid follicle having a cells. That cells is called as a follicular cells. Here, what I have shown. Inside this follicular cells, at the center part, you can see the colloid. Colloid. It is a full of thyroglobulin. Thyroglobulin. This is very important again. So three parts are very important. Thyroid follicle, complete structure. Each cell, thyroid follicular cell, and inside colloid. That point is very important. Now you can see, and these are the capillaries which are present at the side of the cell. Capillary, small capillaries, blood capillary, and this is called as a capsule. You know that capsule is always present outside only, not inside, because it covers. Capsule covers. That is a technique what you have to keep in your mind. C cells are there. C cell is also called as a parafollicular cell. We know follicular cells here. Parallel to that cells, there is a parafollicular cells are there. Parallel to the cell. This parafollicular cells is called as a C cells. Why it is called a C cell? It releases a calcitonin. You got my point? Yeah. Calcitonin. That's why C. Parafollicular. Here I have shown thyroid gland secretes the following hormones. Number 1, thyroxin, X, 4 ends, T4. Triiodothyronine, 3 is there, T3. Considered as a thyroid hormones. It is secreted by the thyroid follicle. Thyroid follicle. Okay. Whereas a calcitonin, not considered as a thyroid hormone, but it is released by thyroid gland. Secreted by the parafollicular cells. Parafollicular cells are also called as a C cells. Calcitonin. Yeah. Thyroid, here the same explanation I given in the running matter. The same points. Thyroid gland is composed of over a million of cluster of follicles. Thyroid follicles. Follicles are spherical, like rounds, spherical, and consist of epithelial cells surrounding a central mass. Central mass is called as a mammum mass. Colloid. Normal thyroid gland secretes the thyroid hormones. Natural hormone compounds having a biological activity. Iodine, L-thyroxine, X is there, T4. It is also called as a tetra. Tetra means 4. Tetra iodo L-thyroxine. Leothyronine. Leothyronine. 9 is there, no? 9. 3 into 3, 9. Like that you can remember. 9. 3 into 3, 9. Thyronine. Okay. Both forms are available for oral use. And parafollicular cells secretes the produces the calcitonin. Thyroid hormone functions. 6 functions are there. Mainly 2 important are very important. All 6 are important. 2 are very important. Normal human growth and development, especially central nervous system. In adults, maintain the metabolic homeostasis. Metabolism important. Metabolism. BMR. Basic metabolic rate is maintained by the thyroid gland. In adults, it maintains the metabolic homeostasis, affecting the all organ systems, not only one organ. That's why it is important gland. Yeah, thyroid we know very well. In our relative also, in your family also, there will be number of thyroid patients are there. They are increasing day by day. Thyroid is nothing but metabolism. Metabolism is nothing but thyroid. Like that you can keep in your mind. Metabolic rate. Metabolic disorders takes place if your thyroid gland is not working. There is a 2 types of thyroid dysfunctions are there. Hyperthyroidism, hypothyroidism. Hyperthyroidism, name itself indicates hyperactive. Your thyroid gland acts overaction. Will do some extra action, overaction. So what happens? Metabolism will be over metabolism in your body. So you'll become a thin. All your body fats, all your carbohydrates in your body will be metabolized so that you will become a lean. See here, over metabolism, hyperthyroidism. So you will become a lean. See hand here, very lean. See the structure. Hair fall will be there. Hair fall. See, hair fall will be there. And see, this is called as a hypothyroidism. And you can find the weight loss here. Weight loss. Because your body will become a very lean because hyperaction of the thyroid. Whereas here hypothyroidism, under metabolism, coarse, very thick dry hair. You can see here. And you will become a fatty. See here, stomach fatty, hand is also fatty, and you will get a weight gain here. So weight gain, hypo, weight loss, hyperthyroidism. These are the some of the hypothyroidism symptoms. Hyperthyroid symptoms: hair loss, bulging eyes, goiter, excess here, goiter, swelling of your thyroid gland, enlarged thyroid, okay, heart palpitations, tremors, heat tolerance, sleep disturbances, weight loss, shortness of breath, diarrhea, increased appetite, irregular menstrual periods, muscle weakness, sweating, anxiety, nervousness, depression, mainly depression, mood changing, mood swings will be, because if your mood is going on changing, you just go and check up the hyperthyroid, check for thyroid gland. Okay. And here also these are the symptoms like a constipation, opposite to these are the thing. Okay. And biosynthesis, yeah, this point is important. Synthesis, the synthesis, storage and release of T4 thyroxin, T3 triiodothyronine, how takes place? 5 steps are there. 1 2 3 4 5 5. Okay, punch. 5 steps are there. First step is iodine uptake or iodine trapping. Either uptake or it is also called as a trap. Number two, oxidation and iodination, both oxidation as well as iodination. Three is coupling, like this, coupling. Fourth is storage and release. And fifth, peripheral conversion of T4 to T3. T4 to T3 conversion peripherally means side. Yeah, this diagram is important. Whenever they will ask in the examination, 5 steps you have to write. See my cursor, 5 steps I will show you first. Trapping, iodine trapping, I showed no. And you first keep in your mind, this cell is nothing but follicular cell. Here you can see colloid inside the follicle, thyroid follicle, colloid. This is the follicular cell. Where it, which step takes place where? That point is very important. See, first iodine trapping takes place here. This is the iodine trapping. 5 steps, what we have shown, the same 5 steps I've shown. Number two is oxidation. See, thyroid peroxidase. It takes place in the colloid. Second step, colloid. Third step, endocytosis. Second step, see the arrow marks. Third step, endocytosis. It takes place in the colloid only. And here, fourth step, proteolysis and secretion, T3, T4. Fifth step, secretion. Directly it is secreted into blood. So this is a fourth step. Okay. So keep in your mind this. I will show you step to step separately now. First one is iodine uptake. It is also called trapping, iodine trapping. Okay, iodine salt you have to use. Here I have shown iodine salt is very important for your thyroid gland. And just like a love trap, iodine will be trapped very nicely. Nowadays all loves are calculated loves. Either he is having a property, she is having a property, only one daughter or two daughters, or like that, they will calculate and they will start loving. Very important point. So it is trap, just like a love trap. Here also iodine will be trapped by the follicular cell. Okay, this is thyroid follicle. Inside you saw the colloid, we know very well. Okay, see, iodine and sodium both comes trapped very nicely. That is the first step. Thyroid cells have an active transport process. Sodium, iodide, symporter, both comes at a time. That is called a symport, not import or export. In the same fashion, symport, two club together and it comes. That is called a symport. Sodium, yes, symport, you can match it. Sodium, iodine, symport, it enters trap. And oxidation, second one, and iodination. So oxidized by the thyroid peroxidase. This is a very important enzyme which oxidize the thing. Okay, enzyme linked to a, and you will get a, to form a monoiodo Thyronin. See here, MIT will form, DIT will form. DIT is nothing but diiodo. Two iodines will be there. Two diiodotyrosine, monoiodotyrosine. Okay. Now these points are important. MIT, DIT. M means mono, single iodo. D means two. Two iodines will be there. Now coupling. Now we know no, T3, T4 we know. T3 means how many iodines? 3 iodines. So what happened? One MIT plus one DIT. Here 2 is there, here 1 is there. So both are coupled like this. Coupled. So here 2 is there, 1 is there. And it forms a T3, triiodothyronine. Whereas one DIT plus one another, here I have shown, see here, MIT plus DIT, it forms a T3. This is called a coupling reaction. DIT plus DIT, it forms a T4, thyroxin. Next is storage and release, just like a godon. So MIT, DIT, T3, T4 all are attached to the thyroglobulin and stored in the colloid thyroglobulin molecule. Colloid, okay, taken up by the follicular cell, okay, and it is processed of a endocytosis. That is another concept, endocytosis, exocytosis. Okay, T3 and T4 are released and also MIT, DIT, okay, deionized, it results in a, okay, finally how much amount? Normal human thyroid secretes the 60 to 90 micrograms. Mu, not mu. Mu means micrograms of T4, 10 to 30. This is very important. How much of quantity? T3 is 10 to 30 micrograms of T3 daily. Next is peripheral conversion of T4 to T3. See, T4, it loses one iodine and it converts into T3 peripherally. Okay, peripheral tissue, especially liver, kidney, not in the thyroid gland. Convert T4 into T3 by the enzyme. This enzyme is important. Iodothyronine deiodinase. Because we are removing one iodine, no? That's why it is called as a deiodinase. Deiodinase and thyronine. Iodothyronine. 9 means 9. 3 into 3, 9. Okay. And drugs like here these drugs are important. Okay, propylthiouracil, amiodarone, propranolol, and glucocorticoids inhibits the peripheral conversion. Transport, metabolism, how much amount will be transport and how the excretion will be there. Plasma T of T4 is plasma T of T4 is 6 to 7 days. Okay, highly bound to plasma proteins. Okay, only 0.04% of T4, 0.2% of T3 are free from binding. And this is a secretion regulation of thyroid T3, T4. See here, this is a thyroid gland. It releasing a T3, T4. If in the blood there was excess amount of T3, T4, it gives a negative feedback. Negative feedback, very important word, negative feedback. So that what happen? Anterior pituitary gland releases less amount of TSH. Like that, it will be regulate, auto regulation, own regulation, negative feedback mechanism. Okay, and actions, growth and development, normal growth, normal development will be there. Metabolism, lipid metabolism is very important in thyroid gland. Okay, and carcinogenic and serious cardiovascular system. T3, T4 increases the BMR, basic metabolic rate. Hyperthyroidism, tachycardia, tachy, your heartbeat will be tack, like that. Bradycardia, very broadly, your heart will be beating. That is called a hypothyroidism. Okay. So, and this is a mechanism of action. How the, where it, TR, you can remember, this is a very important. tRNA, you know that this is RNA, messenger RNA, tRNA, all you know very well. Genetically, transcription will be there and it produces on the, it works on the gene and produces the proteins. TR, tRNA. tRNA is very, very important. So this T3 will act on TR. Okay, trans RNA, and it shows you. Here you can see the TR. How the mechanism of action, it binds to the ligand binding to the TR. Okay, And these are the various sequences will be takes place, and finally anatomic effects you will get, undergo conformational changes, etc. and all. Thyroid gland normally secretes the mainly T4 will be secreted. Thyroid gland 70% of T3 is derived from T4 only. See, mainly T4 will be released. T4 is peripherally, it is converted into T3. 70% of T3 comes from that only. T3 is 5 times more potent than the T4. That's why in the mechanism of action also T3 is main important. Produced as a T4, T3 also produced mainly T4. T4 converted into T3. The T3 will be shows the action on TR, trans RNA. Okay. Next seminar, next class is thyroid preparations. Right. So in my playlist, I have kept all my subjects that you can watch.